Okay, here we go. So everyone, welcome back to the show entitled Teaching with Me. Let me pull up the chat. Perfect. Okay. So the title of this course is Human Motor Control and Learning, and that is obviously what the topic of the course is going to be. So initially what I wanted to do was just introduce sort of the terminology or what this course would entail in terms of material, go through the syllabus, and then we'll actually have a lecture, an introductory lecture, but a full lecture just to get into the material. At any time, always ask questions. I like sort of feedback and interaction. I think it helps us all just sort of learn the material better, and it makes it fun and engaging. So before we get started, is there anything that you guys wanted to discuss? Like I said, this lecture is being recorded and will be posted so that the students that aren't able to be here today, or if all of you wanted to rewatch the lectures, you can do so. It would just be posted on Canvas in the modules. So let's get started. So I know the syllabus says that there are lectures, I think, Monday and Wednesday. The way that I want to structure this course, if you're all okay with it, is to have the synchronous lectures, so me logging in and doing a lecture on Wednesdays, and then I would post the recorded lecture right after that. There are set labs times that you had all registered for when you had obviously enrolled in the course, but because of COVID and the code restrictions and everything changing, what we've done is I've conferred with the TAs and we've decided to make the laboratories all virtual. And so I wanted to go through sort of the process of how that would look, but you're going to have, I think, 5 different labs, and they are going to be due before the scheduled time of the beginning of the next lab. So let me pull up the syllabus just to give you an idea of what that means. Let me just pull up the syllabus. Yeah, so I'm not sure what is on there. Can you guys see the syllabus? A little bit, yeah. That's okay. This is available on Canvas as well, and just make sure that you click on, I think, the syllabus like listing on the side, because this is the most updated one. And if anything changes, I would upload the newer version onto that. But if you can see how the course is sort of broken down week by week, we can see that the lectures are going to be, like I said, the synchronous lectures are going to be scheduled for Wednesdays at this time. And then there are certain labs. Now, originally, the way that it was broken down was you had lab 1 or week 1 and week 2 for each lab. That's not really going to be the case anymore just because of the COVID restrictions. So what is going to end up happening is that we don't have a lab next week, or sorry, that would be tomorrow and Friday. So there's no lab this week, pardon me. And then labs will technically start the following week. So that would be January 27th to 28th would be the initial start of the labs. Now, as I had mentioned, that all the labs are going to be virtual. So they are going to be sort of on your own time. Everything's been posted. And then the way that the sort of labs will work is that what you're going to do is you're going to log in to Canvas, and then you'll see under the modules that there is a sort of the lab protocol section. So there's sections for each of the different labs. Lab 1 and through 5 are all going to be virtual. And what you would do is you would log into a video showing the lab protocol. And just like in neuroscience where you had the embedded Kaltura quizzes, you can have a very similar, I think there's only 2 or 3 or 4 questions per lab protocol, but the same thing where you have a video and you have to answer questions throughout it. And then that will be a part of the percentage of the lab. And then you have sample data that you will use to complete questions that are also posted, and then you submit it through Turnitin, and that's all through Canvas. Now, the labs are going to be due before the beginning of the next lab. So if you look on the schedule, I'll answer these questions in a second. If you look at the schedule, you can see how there's 2 weeks for each lab. Sometimes there's a study break in the middle, and sometimes there's no lab during certain times. But generally, you get about 2 weeks to finish each of the labs, and you can do them on your own time. Now, what the TAs are going to do is they're going to email after for a Google Meets link and a potential time that you could log in and then as a group answer questions, rather than the TAs having to answer like the same question on email over and over and over again. And they will. It would be much easier for everyone if they just log in and you guys can all ask questions as pertained to the lab protocol, but obviously to do the lab reports for each lab with the TAs then. So let me just get to these questions here. So Angie's asking, the labs are not synchronous. No. So the labs are going to be, like I said, all virtual, so asynchronous on your own time. And the sample data that you would have collected in lab is going to be posted, or is posted already. Everything should be up. And then if things potentially change, like I think, what was the date now? They said January 31st, potentially things could return to in class. I would talk to the lab coordinators that if you guys wanted to go in on a certain scheduled time, you could go in and sort of try out the lab. It wouldn't be for credit. It would just be to test it out for fun. Ali, so the difference between this lecture and the one that's already posted is that in this one, you're a part of it. So I've heard that makes it better. Things change a little bit each year, and depending on, obviously, the way that like the sort of lecture goes, it's always a bit of a different interaction and stuff. But I just wanted to post last year's lectures just to see if you want to get ahead and go through the material you can. Do you want me to keep up the old ones? Because what I was going to do is after this lecture, like post this one, not last year's. So if you look, Benjamin, on the syllabus, it will be 5 different labs. So lab 1, lab 2, lab 3, 4, and 5. Was there a difference between this lecture and the lecture that you already posted on Canvas? Oh yeah, that was the same question. You guys okay? Nope. We don't have lectures. Just try to refer to always to the syllabus. Always ask me to. But yes, just to confirm for Andrew, there is just the synchronous lecture on Wednesdays. We're good to go? Awesome. Okay. Stop sharing. Post this here. Okay. I'm biased in my opinion, of course. Unless we're talking about like physical size, it would probably be the opposite of that. Yeah, or age. You guys good? So this is actually the breakdown of the course here in terms of marking. Obviously, you guys are wanting to know that. So we have the 5 labs. Each one is going to be worth 4%. So remember how I talked about the sort of video lab protocol that you would log in and get an idea of what the lab should be, and then you would take your sample data and then do a lab report. The completing of the quiz will be 1%, and again, it's like a Kaltura embedded quiz. So of the 4% per lab, 1% will be that quiz, and then the 3% will be the lab report, and that's submitted and graded by the TAs. There are 4 different online quizzes that are going to be due 2 before the midterm and 2 before the final. And they are just basically a set of like 50 questions that you can go log in and log out and change your answers, keep logging in, talk with people, get your answers in, and then you just submit them before the midterm. So it's a way that you, instead of like a sample midterm, you could go in and go through the material, answer all these sample questions, and get used to sort of answering questions on the material and get you thinking. And there's no time limit. So there's two, I think there might be available now, or they might be available by the end of this class. The first two are available. The first one's going to be lectures 1 through 4, the second one 5 and 6, then the midterm. So they are two quizzes of 50 questions that you would go in and answer on your own time and then submit before the midterm. And then we'll have a similar case where you would have 2 quizzes due before the final, and those would be posted after the midterm if they're not already posted now. And they would be on lectures 7 and 8, and then the second or the fourth quiz would be on lectures 9 and 10. So hopefully that's not too confusing. Those are worth 2.5% each. So there's 4 of them for a total of 10%. The midterm is going to be on March 9th on lectures 1 through 6, and it is going to be worth 23%. And then the last day of classes at midnight, so the very end, there's going to be an assignment. Now the rubric and everything in terms of the marking guide for the assignment is already posted, so you can go through and look at that. I might have to adjust the dates, to be honest, because it was from like the last time I taught the course. The rubric, it wouldn't change at all, except maybe the dates. But what you have to do is you have to pick a motor skill. I'm going to run out what that means, but like sort of like a physical action. And then you're going to discuss certain questions also in that rubric pertaining to the task that you pick. The midterm is going to be, I think, yes, that has to be like it's all going to be virtual, but it's the webcam thing now. What's that called? Respondus? That was the Respondus? Yeah, yeah. I think they changed the and if you look at the what the student has to do on whatever legal thing that they did, that they have to have a computer with a working webcam and stuff. They had put that in because obviously there was a high incidence of people's webcams not working during virtual midterms. First couple times they did it. Strange. So you guys okay? Does that make sense? I know that maybe it's a little bit confusing in terms of like sort of the labs and online quizzes, but are you all okay with the breakdown of how you would be evaluated in the course? Perfect. This is the textbook. There's now an 11th edition, so this is the most recent one. To be honest, this is a really great textbook. The lecture slides, the material is based off of also this course, this material as a field, but examples come from the textbook. So I really like this textbook. They gave me a free one. But they get much deeper into the material, obviously. Like I said, this course is about how to really, if you wait to sort of like think about it, this course is how do you develop, or the history of the development of studies analyzing motor skills. And so what we find is that the textbook has a lot of examples of the different research that's been sort of done over the years. So it's a great way to, because I'll talk about, oh, they did this in the past. This goes into much more depth of that specific information. So, like I say always, if you go through the first couple lectures, maybe try some of the sample questions on the quiz, the ones that are posted. And if you don't get the material, then you can always search a free PDF of the textbook online. Or if you're feeling comfortable, and then it is what it is. Like everything that I do in my courses, all of the questions will come directly from the lecture slides and in the lab protocol and the lab reports, obviously. It does actually kind of, eh? Guys, the reason why I chose this textbook is because I got a sick modeling contract, and that's me. I'm really good at Tai Chi, and actually, that looks like when you go to a like a resort and someone does like the aquafit aerobics for you. This is what it looks like. Okay. Now, taken from the syllabus, this course looks to build on sort of the principles of human movement that you learned in Intro to Movement Neuroscience, except it's much less a neuroscience course, and it's more based on the physiological, psychological, and behavioral aspects underlying human movement. So it's more about remember how in neuroscience, if you took it, if not, that's fine. We said that there is also the way to understand how we sort of voluntarily and involuntarily cognitively control our movement. This is what this course is about. And initially, the course is talking about how we came into figuring out all that information out because it's a newer field. This course starts off by talking about some of the problems that early researchers had when trying to research how do we control movement. Like, for example, think of like a baseball pitch. How do you control how your body moves to throw the baseball? Your bodies tend to work on goals, right? So if you look at, I want to, throw this ball in basketball through the hoop, there's a bunch of different ways to figure that out or the way to do that. So how does your body figure out what's required? And there's obviously a lot of research behind it trying to figure that out, but also trying to figure out how in certain situations, like let's say I'm playing darts, I can be good when I'm alone, but when I'm under pressure and there's some people watching, then all of a sudden I'm not good at a skill. Now, what's the basis behind that? That's more of like a psychological or behavioral aspect, but we can notice that when people are stressed, they tend to have a poor performance on whatever type of motor skill they're doing. So the course breakdown is into 4 different basic components, 2 motor control and 2 motor learning components. We are first going to understand the classification and measurement of motor performance, and that is your ability to perform a motor skill. So by being able to classify and to measure, then we're able to do studies, and that's how we develop a knowledge base in a particular field. We're going to look at the role of different sensory processes in our ability to achieve different tasks. So is vision important? Is proprioception important? How do things change as we get better at something? Do we use different sensory processes? What happens if you learn using a particular type of feedback and that's gone? What happens then? Are you now not able to do it, or can you adapt? Things like that. We're going to look at memory and attention. So thinking about how we memorize different motor skills. We've all heard the old saying, you never forget how to ride a bike. That's one interesting thing about motor skills, is that as you learn something, you tend to never really forget it. You may get rusty, but it seems to be stuck in your brain permanently, which is interesting, right? Because half of you can't remember when, I don't know, things you learned in the, in other courses, right? Attention. So one thing is that we notice that there is a decrease in performance when you're multitasking or doing multiple things at once. What's the basis behind that? And then we're going to finish off with trying to understand what types of feedback to give people with coaching them and allow them to learn at a faster rate. What are some of the principles behind that? And then how to optimize practice to have people learn the motor skill that they are trying to teach quicker. So that's how the course is sort of broken down. And this is it all right here. And then today we're going to start off by sort of introducing motor skills, the term motor skills. And we're going to talk about what motor control is, what motor learning and motor development as terms and why they're different. We're going to look at sort of the terminology that are used in research to describe motor control terms. So ways to describe motor skills. So we're going to learn these terms. And then we'll finish off with how we initially learned to classify different types of motor skills. And that was a sort of a problem that took a lot of different times, because let's say for all of you, we're going to learn how people control voluntarily are able to learn new tasks. So is picking up a cup and drinking from it the same as learning to throw a baseball? Is learning to is DDR still a thing? Dance Dance Revolution, or like one of those like dance games? Is that the same thing as learning to change gears in a manual car, if those even exist anymore? You're still moving, you're still voluntarily controlling your body, but they're two very different types of actions. And so how do we differentiate different types of motor skills? And that's where research sort of started off as the big question to answer. Any questions, guys? Am I going too fast? Am I going too slow? Leka? No, you're good. Okay, so I have just a quick video to show you guys. I don't know if you're going to be able to hear it. I think you can. Start. Play it. I think it's loading. Ready? Maybe turn up your sound and let me know if you can hear this. Yeah, it's not working. Oh, you guys ready? Please work. Please work.
Motor learning control is an important and rapidly expanding discipline. It is the study of how motor skills are acquired and developed, and is important in rehabilitation and performance. This video will cover the history, some theories and models, and the future uses of motor learning and control.
Motor learning and control really just became a research area in the 70s, though there was research done similar to what we consider motor learning and control research. So a psychologist named Franklin Henry was doing a lot of motor learning research. And in that motor learning research, it was considered part of psychology because it's like controlled by the brain, etc. So he was really interested in how humans acquire and control skilled movement. So he was writing a lot of research about findings about pre-processing and etc. And he wrote a seminal paper saying, and I think it was published in 71 or 72, saying we need to move away from psychology, move away from physiology, move away from like other tangential areas and create a kinesiology. He suggested using the term kinesiology, and create a more scientific society where we do our own research. We have our own societies, like the North American Society for the Study of Sports Psychology and all different kinds of cognition. So he actually created that society. So his work, and he was an instructor at Berkeley, and Dr. Schmidt, who is at UCLA and has a bunch of theories out there, was his student. So Franklin Henry pretty much consolidated the area that we now know as motor learning and motor control, and through many papers saying we need to do our own research and be more scientific and get into human factors, not just mental factors or whatever.
The first model is simple and choice reaction time. Simple reaction time has only one choice and a quick response time, while choice has many choices, is a longer reaction time, and the more choices available, the longer reaction time. Next is the fits and pause learning model. The first stage is the cognitive stage, where there are many errors and gross movements. The next is the associated stage. There are less errors and the person gets slowly better at the skill. The final stage is the autonomous stage, where there are few or no errors and the person does not need to pay attention to the task because their movements are autonomous. Next is discrete versus continuous skills. First, we have a discrete skill, where there is a clear beginning and end to the task, versus a continuous skill, where there is no clear beginning and end, such as a person jogging by. Next is open or closed environments. An open environment is where there are environmental factors to consider, such as another person to rally with, or going against a defender in basketball. In a closed environment, there are no environmental factors, such as shooting a free throw alone. Next, we have fine versus gross skills. A fine motor skill uses very small muscle groups, while a gross motor skill will utilize many muscle groups and use large ones.
Awesome. So I like using that video for two reasons. Just to clarify, so I like using YouTube videos as well because the program, like a YouTube, they automatically close caption stuff for you. So if the link is in the lecture slides that are posted, you could always go in and sometimes it's hard to hear what they're saying, but it'll write it up for you. But I like using that video because it gives you a history of motor control and learning research. And it's interesting because it's that research that came from behavioral psychology. The interest in learning to move is what sort of allowed for the kinesiology program to be created. So I don't know if all of you are in kinesiology or just strictly health sciences, but it's interesting to note that of all of the different courses, that's where kinesiology as a field came from. And then the second reason why I like that video is because it's a good introduction to the sort of things visually that it's a visual introduction into the things that we're going to be learning today in class. So why do we want to study motor learning? What is it about motor control and learning, or the ability to control one's movements, that is interesting? Now, we are all born to move. All animals are born to interact with the environment. It's a biological imperative that we need to be able to interact with the environment surrounding us. We need to be able to find food, eat it, take care of ourselves, move from one place to another, learn how to climb, learn how to swim. It is a sort of biological necessity. Now, with humans, we are unrivaled in our capacity to move around. Now, if you look at us versus other types of mammals or other even types of animals, we are unrivaled in our ability to watch and learn how to do different things and be able to do more and more complex tasks than any other animal or any other sort of living creature, right? So this sort of course is looking at what is it about us that is giving us that ability to do that, right? And hopefully that interested you or not bored you, but that's sort of the impetus of why we want to learn this. Now, what term that we need to discuss is sort of the voluntary movement to manipulate your environment. That's called a motor skill, or the performance of a motor skill. So our purposeful movement is defined as the performance of a motor skill. Now, what do we learn about when we think about learning a new task? Let me ask you guys a question. What is the main way that we learn something and get better at it? In terms of a motor skill, sorry. Yeah, repetition, right? That seems to be the process. For whatever reason, the way that we're wired, we either figure out, so initially what would have happened is that we would notice something that we needed to do, and in caveman times, it would be because of a biological necessity. And then humans, through repetition and troubleshooting, would figure out what to do. And what's the next thing that humans are able to do that's so different than other animals? We're able to, so if someone else, well, evolve, yes, we're able to do TikToks. We are able to watch. So let's say someone's learned something and what to do. We're able to watch someone do it and then do that. So what is it about that, right? So this is sort of like some things to think about as we're going through the lecture. Imitate. That's it, intimate. So here we have a video. This is another quick one.
The path the human baby takes isn't always
So this is an example of how we are learning things through repetition.
Of hills and valleys of varying degrees. The body must learn how to adapt, and the mind must decide what's safe and what's risky. Hannah is 14 months. How she decides to negotiate the ramp as it gets steeper and steeper will depend on how much experience moving around on her own she's already had. Each new attempt places more demand on her for control of her movements. This incline looks like more than she can handle. Her feet pat the ground and deliver the message. This problem needs another solution. Dr. Adolf ups the ante. But the situation has gotten out of hand. Hannah tries to explain the problem. She gives it a try, but it's time to call for help. Hannah is in a pickle. Even though she has a lot of knowledge about her physical abilities, this time she prefers to depend on an adult to help her find another strategy. Experience has taught her that this slope is just too risky to attempt.
Perfect. So through knowing, like even as a young child, and this is how we're going to learn motor skills, like all of us, is through repetition, right? We're going to understand our own boundaries. That's something that humans can do. And we will look at a task that needs to be completed, and then through repetition and troubleshooting, try to figure it out. What's the other thing that we can do is that we can get help through imitating or getting other people to help us, like coaching, for example, to help us learn at a quicker rate. Clinically, I always like to bring things back to clinical stuff. Sort of this research or the evaluation of how we perform motor skills is important, because if we understand how we learn and do motor skills or perform them, we can understand how we can take some, like in a coaching situation, make people that are doing a sport and make them better, or we can look at it sort of like in a rehab environment, that if someone has lost coordination as a result of like a neurological disease or even an injury, how we can improve and have them relearn or adapt to being able to perform that motor skill again. Now, the course is called Human Motor Control and Learning. So what's those two terms? Half the course is about motor control, and then half the course is about motor learning, in a sense. They're both within the same sort of branch, obviously, because they both pertain to the study of motor skills. And like I said, motor skills are defined as activities or tasks that require voluntary control over the movements of the joints of our body to achieve a particular goal. So it's purposeful actions. And human motor control and human motor learning research are sort of combined in the fact that they both study motor skills or voluntary movements to achieve a particular task. Motor learning specifically involves the acquisition of, or the study of the acquisition of motor skills, the performance enhancement of learned or highly experienced motor skills. So taking like an amateur athlete and making them elite, for example, something that you've already learned, how do you make it better? Or the reacquisition of skills following injury and disease. So all of those would involve learning, a learning component, learning a new task, relearning a task that you were unable to do because of an injury, or taking a task that you are able to do well, but learning to do it even better. Those all involve motor learning. I had asked you guys, like, sort of, what are some of the things that you sort of notice in people that are learning different motor skills? And we all said repetition or practice. The process of us learning motor skills comes from this whole idea that practice makes perfect, that the repetition of doing or attempting a particular motor skill allows us to get better to achieving the goal of whatever it is. And then as you get better and better and with more and more repetition, you can do that skill with an increased capability to perform under different and varying conditions. Like, for example, if we are learning to shoot a basketball. Now, initially, think of someone that had no experience. They are just going to learn probably at the free throw line, just learning how to get the ball in the hoop. But when someone becomes an expert, they'll be able to hit a jump shot with a defender on them when they're running, or they're fading away, or they're jumping or off the backboard. As you become better at something in terms of a motor skill, you're able to achieve that motor skill under a greater and wider range of situations. And that seems to be something that is consistent in motor learning research, that is observable. And that's the key with motor learning, is that there's it's very difficult to sort of assess how much someone has learned a motor skill, right? In terms of testing, you can do academic testing. You give them questions about course material, just like these quizzes or the midterms, and then that will let you know how much you've learned of the course cognitively. It's much more difficult to sort of assess learning in terms of a number when you're looking at a motor skill. You have to sort of come up with sort of measurements to assess performance. How do I know that, how do I know that Karen is better at, what's next? Andrew than at swimming? You would have to have people perform the motor skill and observe their performance. And then sort of come up with sort of variables to measure their performance, and then you would compare. Where does this learning occur? Actually, now we, in my research, Ontario Tech, motor skills are sort of evolved in the cerebellum, and we'll get into that throughout the course. But one interesting fact is that once you've learned a motor skill, it tends to be stuck in there. Unless you have like sort of a stroke or something that damages parts of the brain, that information that you've learned in terms of performance of that motor skill seems to be permanently in your brain, which is very interesting. Motor control also involves the study of motor skills, obviously, but it is more sort of looking at, in terms of the research or out of the field, it's looking more at the study of the behavioral and the neuromuscular mechanisms that produce coordinated movement. So what we're going to do is look at sort of the ways that people control their body. So the neurology, cognitively, what they're thinking about, what parts of the environment they're considering when they're performing a motor skill, and how their performance in the motor skill changes as they're learning a new skill versus when they're performing a well-learned skill. What is one thing that we notice? I don't know. Do you guys have any coaches or anyone that works with kids in the class? No. What do you notice about kids that are learning anything new for the first time? They are super uncoordinated. Would that be an accurate statement? Right. So, and slow, and they're kind of all over the place. But as they get better and better, they become more efficient. Think about the motion. It becomes more fluid. So does that mean that the motor control has changed? Or are the neurons different, or are they better able to understand the environment better? What's the difference in someone that is learning to do something versus someone that is good at doing a particular motor skill? What's the difference in the control of the body that allows them to do that? Does that make sense? That's the question that you're asking in motor control research. Because if we understand how they do it differently when they are an expert at something. Maybe we can teach other people to do that, to learn quicker or to heal from an injury. Now, there's different levels of analysis when, sort of evaluating someone's ability to control their body when performing a motor skill. We can do it observationally and behaviorally, and that's where sort of research sort of started off in terms of behavioral psychology. We can look at the relation between things in the environment. Let me give you an example. When we are learning to play baseball, what do the coaches first say when we're trying to hit a baseball with a bat? Look at the ball, look at the ball, look at the ball, look at the ball. That's an interaction between our ability to perform the motor skill and the environment. So we want to look at the factors that allow us to perform a motor skill and how that changes as we get better and better at something. Biomechanically, we can understand sort of the mechanical or physical basis of movement. So you can look at sort of the math as to why people would move a specific way. Usually it's in terms of efficiency or developing the right power in the certain areas. But what about how does that change over time? Maybe we can look at the biomechanics of someone performing a skill and understand that the biomechanics show that they are more efficient when they're performing a skill as when they're an expert versus when they were learning the motor skill. And then we can look at exactly. So like the term muscle memory is true, right? Like we say, oh, it's muscle memory. Your body knows how to move. Mohammed's saying that. So that's something we've all heard before, right? The term muscle memory, it's true. But where does that sort of learning happen? Is it because we've learned to become more efficient, or have we changed the neurophysiological or neuroanatomical control of our body? Has our central nervous system or our brain or our cerebellum learned to optimize how to send out motor patterns, or are we better able to understand the sensory information in our vision, in our proprioception, in the environment? Are we better able to pick out certain things? And that's what this course is going to sort of answer for us. So, as I was saying, we can use that information to learn how different variables that affect our ability to perform certain things. So, looking at sort of like reaction time, we can look at speed accuracy trade-offs. So, if you want to do something accurately, people tend to slow down. If you wanted to like draw a nice perfect circle, a lot of people would slow down to do that task, versus if they're doing something quick, it tends to be less accurate. So it's quicker but less accurate. That's another variable that we could see. Multitasking is a big one that achieved a lot of research. So when we do multiple things at once, typically when we evaluate the performance of those motor skills, when we're multitasking, there tends to be a decrease in the performance of whatever you're multitasking. Except as you get better and better at a particular task, you can multitask without the same detriment in performance. So these are all factors that things we will look at throughout the course. And then obviously the research for a lot of like the people that go on to clinical stuff, it allows us to develop sort of standards and guidelines when coaching, when we're like doing treatment programs for physical therapists or rehab, or like coaching paradigms for people that are training people. Any questions? My goal was just to kind of get you guys interested. Hopefully I succeeded. Everyone okay? Awesome. Motor development is a whole other course. It's looking at motor behavior, how that changes from infancy to old age. That would be another course that I think you guys are taking right now. Is Megan Lloyd still teaching it? Okay. So that's not super important, but that's another sort of branch of motor control and learning research. Motor development is looking at how our motor system behaviorally develops and changes as we go from child to old age. So we're going to continue on and just start discussing a lot of the intro research, the questions that people were sort of asking and figuring out when they branched out from behavioral psychology to kinesiology or motor control sort of research. This research assumes that our ability to perform motor skills is influenced by 3 different things. And we're going to see this throughout the course, that there's 3 different factors that are going to affect our ability to perform a motor skill that we are learning. The skill itself, so whether or not it's a difficult or easy task, maybe it is really, think of a huge dance routine versus a very simple kick over a bucket. The degree of difficulty of the task is going to influence whether or not we're able to achieve that motor skill. The performance environment, that's going to affect our ability to perform a motor skill. Now, think of it this way. So how many of us, every time we are trying to throw out a piece of crumpled paper, do we do the Kobe RP into the trash bucket? Right? You know, we're all good at throwing, crumpled up pieces of paper or trash into the wastebasket, right? Now try to do that while we're on a conveyor belt. Have you ever tried, I don't know, I can't think of an example, but maybe you're walking and then trying to do the same task. It makes it more difficult, right? The performance environment will also affect or influence our ability to perform motor skill that we're learning. So if there's things moving in the environment, if the ground is uneven, if things are unstable, that's going to change our ability to perform that. Maybe there's something in the way that's blocking your vision, or maybe the lights are off so you can't see something. The performance environment is also going to influence our ability to perform a skill that we're learning or know how to do. And the last thing is the physical or psychological characteristics of the person will influence our ability to perform a skill. So think of it this way. So we're able to perform a motor skill. Now, what happens when we're doing it in a competition, when the pressure's on or there's loud noises or you're very, very stressed out? Depending on the type of motor skill and the type of sort of situation, internal factors will affect our ability to perform that skill, like stress, right? So we have the external environment, the internal environment, and the skill itself are the 3 different factors that are going to combine together to influence our ability to perform a motor skill. Okay? So research is going to look at individually these 3 different things to get a better idea of what are the variables that would make one thing harder or easier in that factor to perform the motor skill. So if it's a very difficult task, it'll make it harder, obviously, right? If the environment is so that there's a lot of moving things or things are moving around, that's going to make things more difficult. If someone's more stressed out or they're really zoned in, that can make things easier or harder for them to perform that motor skill. You guys okay? Awesome. Okay, so now we're going to go through these just different terms that were discussed initially and are used throughout the sort of course, the textbook, motor control research, and motor learning research. These are sort of terms that were developed so that way we would all speak the same language, because obviously research is done in different parts of the country, countries, and the world. Okay, so there's several terms. They are skills, actions, movements, and neuromotor processes. So a skill or motor skill, remember, as I said, is a it's a voluntary control of your movement of your body to achieve a particular goal, okay? Whereas if I am just blinking, so let's say I get dust in my eye and I blink, that's one thing, versus if I am like crushing on someone and I give them the old, what's up? I'm voluntarily doing that to get their attention. That is the same motion, but there are two very different neural characteristics. A wink would be a motor skill because I'm consciously doing it. I'm voluntarily trying to achieve a particular goal, versus as a blink would be a reflex. So did we notice the difference? The term skill means motor skill. One thing that you should know is that skill and motor skill is a terminology. The term skilled is a way to be used to classify performance, or it uses as an adjective. So if someone's really good at something, like an expert, I can say they're very skilled in the performance of a motor skill. Skilled, as we can all probably agree, would have what sort of like factors associated with it, or characteristics? Someone that's skilled at something can achieve the motor skill all the time under a wide range of different situations, and they can do it almost effortlessly. It looks like they are way more efficient at doing that motor skill than someone that is learning. Okay, so motor skills is the term skill. Skilled is an adjective. Now, a lot of different motor skills obviously have a cognitive component. So when I am if someone's a quarterback, right, the play begins and they have to cognitively think about where the defenders are, what's the best pass, and then achieve that. Okay, so there's obviously cognitive components of every different motor skill. But with motor skills, the motor component is the one that's maximized. Whereas with cognitive skills, like doing mathematics, for example, right? If I'm doing math or I'm writing an essay, I'm doing, I'm typing or I'm writing on a piece of paper. It involves motor stuff, but the majority of that skill is a cognitive component. So that's a cognitive skill. Are we okay with that? So motor, chess, cognitive. So in this course, we're looking at motor skills. So motor skill can be short form to skill. They mean the same thing. And it can also be interchangeable with the term actions, okay? So my performance in doing a motor skill, my performance in doing a skill, my performance in a particular action, they all mean the same thing, okay? Now, movements is a different term, and I was thinking of something that we could do where I could get people on the to share their screens and perform, a motor task to sort of do this point. I just can't think of like something because it would be funny, but I just can't think of something that would work. Touch your nose. Yeah, it's gonna be a little bit more difficult because the point of the term movements is that we perform a motor skill to achieve a particular goal, right? Yeah. Can someone juggle? Yeah, juggling. Because the thing with motor skills, and this was the hardest part of the research, is that think of like throwing a baseball. If the goal is to throw the baseball and at the batter, there's different ways you can throw the ball. You could throw it underhand, you could throw it overhand, you could throw it sidearm, you could do it two-handed. There's different ways you can achieve the same goal. So then does that mean that the people are doing different skills, or are they doing the same skill using different movements of the body? And that's why research had a little bit of a problem trying to figure out terminology. The term movements is the specific movements that an individual uses to achieve the motor skill. So people can do the same motor skill, like touching their nose, but they may do much different things in terms of the movements that are utilized. So to use like Karen's example, so I want to, sorry, my little wheel missing on my chair. I want to touch my nose, okay? So that is the motor skill, that's the goal. So I could touch my nose, or something stupid. I could touch my nose, or I could touch my nose. Lunges, push-ups. Do you see the difference? If a motor skill is to achieve a particular goal, the goal is to touch your nose, there's different ways that you could do it. So does that mean it's a different motor skill? No, it means you're using different movements to achieve it. And then as you get better and better, you're probably going to figure out the most efficient way to do it. So do we understand why you want to have that term? Movements are the individual movements of the body for that individual when they're performing the motor skill or action. I should have done, I don't know, I can't think of anything. We could have made it funny. But in that relation, the relationship between movements and actions can be described as many to one or one to many. Now, many to one means that a single action goal or the single goal of a motor skill can be achieved in a multitude or many different ways or involve many different movements. Or the same movement can be used in a wide variety of different types of motor skills. So we're talking about, hip flexion. Hip flexion can be used in kicking someone, can be used in going up the stairs, is used in walking, is used in performing, reverse lunges, or, that same movement of the body can be used for a wide range of different motor skills. And then if we're looking at things like from a neuromotor or neurophysiological perspective, it can mean the same thing where we can have a bunch of different firing patterns or muscle motor neuron patterns or motor recruitment strategies that can be used to achieve the same skill. So for example, for someone to walk, you're using, slow twitch, so soleus, versus if they, let's say the goal is to go from one place to another. You can walk or run. Neuromuscularly, you could be doing running, and so you're gonna use fast twitch fibers, whereas walking, you're gonna use more slow twitch. It's the same sort of concept, looking at it both as movements, but also inside neuromuscularly. And the relationship is one to many as well, because you can have similar muscle contractions, right? The activation of fast twitch fibers in the gastroc that can be used for a lot of different motor skills. High jump, jumping, dunking, running. We all okay? Everyone? Awesome. Yeah. And like I said, the reason why we need to be able to differentiate between all of this stuff is because there is a lot of different ways to achieve the same motor skill, or the same movements can be used in a wide range of different skills. So the last part of the lecture, we're almost done, is once research was able to put together all this terminology and get a better idea of how they were going to be able to communicate with each other and do research and then build on each other's research, they had to next classify different types of motor skills, because a typing task is going to look a lot more sort of different in terms of the control process that is going to be used in the body than a running task, for example. What's the difference? How do we define different skills? How do we classify different skills? Because then we can group them together and say this class of motor skills is controlled this way, this one is controlled this way, and then we can sort of compare within. Remember, research is really just about sort of comparison of variables and looking at how the effect on performance, right? And so we classify motor skills because it is sort of the basis for identifying similarities and differences among skills. It will help us identify sort of the demands that are placed on the performer and how it would affect them positively or negatively, or by how much. And then using all of this and comparing, it allows us to accumulate knowledge and then allows us to provide an understanding to everyone about how our body is able to control itself during motor skills, and how it is sort of able to learn different motor skills as it's a process. So initially, there was 3 different one-dimensional systems, or like where it's this one or this one, 3 different one-dimensional systems to classify different motor skills. So we'll go through that now. And then the thing we're going to end off with is Gentile's 2-dimensional taxonomy. And the reason why I did that was because this was developed, I think, in the 90s or 2000s, early 2000s maybe. No, I think it was the 90s, where it was a chart of 16 different difficulties, and it was used in rehab. So you would be able to take something that the patient would need to learn, and you would be able to sequentially increase its difficulty, right? Because as they learn, you want to sort of build on it. It was a way or a guideline to increase the difficulty of learning of a task while a patient is learning, or would be also another way to sort of evaluate someone doing a patient coming in and doing a skill, and then look at where on the chart they are, and then you like sort of build on the difficulty to sort of train them or rehab them from that point. So the 3 different one-dimensional systems are related to the size of the musculature involved, the beginning and end of the action, and then the stability of the environment or the environmental context. Okay, so these are the 3 different one-dimensional systems, and this is where research sort of started. So the first one, and this was actually in the video. Remember in the video at the very end where they were showing someone hitting a ball versus running or something? The first way to classify motor skills is by the size of the musculature. So you would classify something as either a gross motor skill or a fine motor skill. So gross motor skills would therefore be utilizing like the big muscles, so like power movements, whereas fine motor skills would be using fine movements like typing that would involve accuracy and hand-eye coordination. So that would be 2 different sort of neuromuscular motor control processes in a gross movement versus a fine movement. So what they would do is they would be able to classify a look at a motor skill that they wanted to research and classify it as a gross motor skill versus a fine motor skill. Now the problem with any one-dimensional system, and these ones as well, is that things aren't always black or white. They're not one or the other. Sometimes, and most times, they're somewhere in between, right? And so with one-dimensional system, it was always sort of hard to say, well, where on the spectrum of the one-dimensional system would this motor skill that we're researching fall? But it allowed for comparing different types of gross skills versus different types of fine skills, and understanding what might some of the differences be when performing those, or what the differences are in the control of the body during these tasks. For example, when we're doing fine motor skills, things that involve a lot of accuracy, what are one thing that we notice when you're doing something accurate? The speed of the movement slows down. So it tends to be that with fine motor skills, we do things slower to improve accuracy, whereas with gross motor skills and power skills, we can do it faster because they can be less accurate. So that was the first sort of classification system. The second one was the specificity of the beginning and end. Now that sounds a little bit like sort of tricky to sort of understand, but think about this. What about comparing running versus throwing a ball? with running, where, like, what part of it counts as the actual motor skill? Like, so is it the flexion of the hips? Is it one stride counts as one motor skill, or is it the whole time? The beginning and end of that motor skill is sort of arbitrary because it's a repetitive motion. So that's called a continuous motor skill, where it's hard to point out the beginning and end of the movement. It seems to be all one big movement. Whereas discrete motor skills have a defined beginning and end. We have a question from Karen. That changes with practice though, right? Oh, which point? Sorry, I missed it. Oh, yes, yeah. So as we're learning something, and we need to be more accurate, generally it's slower, but as you get better and better, you can do things faster. But with this, do you guys notice the difference between, or can understand the difference between continuous skills versus discrete skills? Because with continuous skills, like, you know, with repetitive skills, anyone can ride a bike. As you're riding a bike and you get going, no one's really thinking about moving their legs. It kind of just happens, right? And then you're more concentrated on the steering and looking, right? That motor control process is much different than trying to do a fine skill where you're trying to touch your nose, right? You're thinking about the actions as you're doing it. So what happens is that it looks like the control process is much different for a continuous skill versus a discrete skill. And just like with all the one-dimensional systems, things aren't typically one or the other. They're somewhere on a spectrum. The last one was talking about defining motor skills based on the stability of the environmental context. So when we say the environmental context, or the environment when someone is doing the motor skill, or the environment where someone is doing a motor skill, we're going to be looking at the environment, which includes three different things. The supporting surface, so whether they're sitting or standing on, the objects in the environment, and the other people in the environment. So the environment in which someone is doing a motor skill is a way to sort of classify it. Because, let me give you an example. Is it easier to hit a ball off of a tee, like in t-ball, versus hitting a baseball that's been thrown by a pitcher? Which one's more difficult? Yeah. I was like, uh-oh. Karen, we got to start back from the beginning. Does anyone not know what, like, t-ball is? You guys can understand the sort of difference in that, right? Hitting a baseball off of a tee is called a closed motor skill, because it involves, a closed motor skill involves the people, objects, or the supporting surface that is stationary, because it's internally paced. I get to choose when I hit the baseball. Whereas a open motor skill involves the supporting surface, people or objects in the environment that are moving. That means I have to time my movement based on things I'm not in control of. That's much more difficult. I have to swing my bat when hitting a pitched baseball based on the timing of the pitcher and the ball. Whereas with the t-ball, I get to choose when I hit it. So it tends to be more difficult when we are externally paced in doing a motor skill. It's more difficult for us to do an open motor skill because we have to time our movements with the environment and how it's moving. Did I say pre-baseball? So can you guys see the difference between open versus closed skills, and why open skills would, like, from a motor control perspective, be much more difficult to do and learn than a closed motor skill? So this were the three different one-dimensional systems that were sort of originally used, because they were a very quick way to understand that the control processes in these three different examples are much different, with fine versus gross motor skills, discrete versus continuous skills, and then closed versus open skills. the last one is Gentile's two-dimensional taxonomy. So just as a definition, taxonomy is a classification system. Like taxidermy is a way to classify animals. A taxonomy is a way to sort of like classify certain things. So Gentile's two-dimensional taxonomy was a way to describe and classify different types of motor skills. Now it's based on two different characteristics: the environmental context, like closed versus open, as well as the function of the action or the type of motor skill, or characterizing the actual motor skill. Because what did we say that there was the three factors that influence motor skill performance? The person, the environment, and the skill itself. So Gentile's taxonomy was going to be able to classify a motor skill based on the environment and the skill itself. So it's missing the internal factors. And this was developed to be used in a rehab setting, because what they would have here is you have two different axes. So this is the taxonomy, and we'll go into what this means, but this was the taxonomy. So you would look at the environmental context, and then when it says function of the action, it's a way to sort of describe the difficulty of the action itself. And then by doing a grading system, you would be able to have 16 different difficulties or ways to classify a motor skill. And so increasing difficulties this way, and then like it continues on. So what you could do is you could look at a way, remember this was done for rehab, so you could look at, because remember in rehab, especially with occupational therapists and physiotherapists in a hospital, it's trying to get people back into daily life stuff. Like, how do you brush your teeth, getting changed, walking, learning to groom yourself, or like go to the bathroom, clean yourself, all that kind of stuff, right? So a lot of the exercises were done on the fly, where, okay, what are the limitations that this person is having with their daily life? They can't brush their teeth. Okay, let's come up with an exercise program or rehab program for that specific action. Okay, well, how do you first learn to pick up a cup? Then how do you make it more difficult? Right? So this was why, okay, so this would be an easier way to sort of guide you into increasing difficulty. Does that make sense? Yeah, awesome. You guys are like so smart. Okay, so let's talk about these axes first, because this is going to wait a way for us to, inter-trial variability, Jacob. That's what that next slide's on. So just remember these axes, okay? Because I'm going to have to go through what this means and then go through what that means. So the first axis is the environmental context. So the environment involves evaluating the regulatory conditions. So regulatory conditions are the objects in the environment, the surfaces, and other people. So just like when we're looking at open skills, the regulatory conditions are the things in the environment that we have to conform our motion to. And then when things are in motion, so open motor skills, they are more difficult than closed motor skills. So when looking at the environmental context, Gentile's taxonomy first looks at if things are moving or not, because that would sort of base whether or not things are more difficult. Non-regulatory conditions are things in the environment that don't have an effect on our movement. So let's say I'm pitching a baseball or hitting a baseball. What if the baseball changes color? So it goes from white to black, or white to, some of them are yellow. It's a change in the environment, but it doesn't really affect the way that I would be moving. Whereas what if I was hitting a hard ball versus a softball? Now all of a sudden the environment objects in this case have changed. So I'm going to maybe change my movement or the skill actions because that would be a change because the ball is bigger, so that would be a change in a regulatory condition. But the environmental context is to basically evaluate whether or not the regulatory conditions in the environment are moving or not. And then with what Jacob was saying, what does ITV mean? The other way to sort of evaluate it is that with each repetition of the skill, is the regulatory conditions changing? So when we look at the environmental context sort of axis on Gentile's taxonomy, we get 4 different options. So we have to look at whether or not the regulatory conditions, so whether or not the people, the objects, or the supporting service are stationary or in motion. And then for each of them, if with each repetition of doing that skill, if the regulatory conditions or the environment changes. So think about golf. So let's say we're playing golf on a golf course. Nothing's moving, right? So the regulatory conditions are always stationary. So every time you hit a ball and you walk up to it and you hit it again, you go up and you hit it again. So everything in each case is always stationary. The environment is stationary every time. But depending on where you hit the ball, every time the environment's sort of changed, right? Nothing's moving still, but the environment's changed. So there's intertrial variability. So that's the one axis on Gentile's taxonomy. The top one, or the x-axis, is called the function of the action. So a way to describe the difficulty of the skill itself. The 3 different aspects of whether or not or how to classify the function of the action or the difficulty of the skill will be whether or not the body is stable or moving. So body stability versus body transport. Body stability, we would be maintaining our base of support in one position, whereas with body transport, the center of mass or your body would be moving as you're doing it. And the last part is whether or not we're manipulating an object. So in relation to fine motor skills, typically fine motor skills require a lot of hand-eye coordination. That's something that we slow down our motion for accuracy. Manipulating an object increases the difficulty of something, and that's something that they notice when evaluating one-dimensional systems. So that gives us another 4 options for the x-axis. So function of the action. Remember, action means motor skill. So the difficulty of the motor skill. We have whether or not the body is moving. And then in each case, whether or not we're manipulating an object. So all in all, what that gives us is this taxonomy. So we have the y-axis as the environmental context, whether or not something is, whether the regulatory conditions in the environment are not moving or moving, and whether with each repetition there's intertrial variability. And then the function of the action, or the x-axis, is looking at whether or not the body is moving, so stability versus transport, and then in each case, whether or not we're manipulating an object. So hopefully that didn't confuse you too much. The best way to sort of evaluate is start picking different motor skills, and then we'll place them on the taxonomy. How would you classify this task? So this is, let's say, shooting a free throw. Jacob, do you want to practice? Okay, so shooting a free throw. Everyone would keep that in mind, okay? Where on the taxonomy would we classify shooting a free throw? So Jacob, in the environmental context, are things when shooting a free throw stationary? So the regulatory conditions, are they stationary or are they in motion? Yep, so stationary. Every time you do a free throw, is it the same, or is the environment changing? Yep, so the same. Because hoop's the same, ball's the same, distance is the same, right? So we are right now here. Now, in terms of the skill itself or the function of the action, is the body moving or is it stable? Okay, and then are we manipulating an object or are we not? Boom. So we would classify shooting a free throw as 1B. Let's practice another one. Ooh, okay, go on. I use golf as an example. But What about Ali, Daniela, Kayla, Karen? Karen probably wants to answer. Who wants to do this one? So this is, let's say, playing golf. With golf, is the environmental context stationary or in motion? Oh, yeah. So I would say that it's stationary actually, because as you line up, the ball's not moving, the pin's not moving, the ground isn't moving, the regulatory conditions aren't moving. So I would say it's stationary. Now, with each repetition of the golf shot, are the regulatory conditions changing? So is there inter-trial variability? Yeah, I know what you meant, Karen. But now do you see how it's stationary and how there's inter-trial variability? Yeah. So we, for a golf shot, are right here. Now, is the body stable or transport? Or is it moving? Stable. And then are we manipulating an object? We are. So we would be 2B. Now, so Karen said we're moving. So remember the definition was that the body is staying in one place. Of course, with doing a motor skill, your body is moving. It's talking about whether or not the body is stable and staying in one location. So now do you see, Karen, that with like the golf shot, it is body stability. So manipulating an object, Pardis, is just whether or not we're using our hands to touch an object and move it around. Because that's more difficult. Me moving something is much more difficult than raising a hand. Fine skills are more difficult than gross skills. Fine skills are more difficult in that they involve hand-eye coordination and accuracy. So Karen, not that the feet are planted, it's that the center of mass, they are planted, yes, but your feet could be planted and you're on a conveyor belt, so you're moving. It's that whether or not the body is stable and staying in one location. Yes, so kicking a ball would be considering manipulation because you are manipulating an object. Yeah, I would say so. Body displacement, sure. Yeah. So body transform would be that there's displacement of the body. Okay, so let's do the okay. No, you are going to describe it. Okay, so Ali. In was it like what's called the rings? The rings like where like they're like that guy, the iron cross kind of thing. Yeah. Okay. So the environmental context is the regulatory conditions stationary or in motion. Yeah, kind of both. You could argue for both because as it starts off, they're all kind of in the same location. But I would say that they are, I would say they're stationary because it's you exerting force that's moving them, right? They're not kind of moving by themselves. It's not like you have to it's not like Indiana Jones and there's like a swinging rings and you have to like try to time you and jump onto them. And this brings a good point too, right? That there is some room for sort of like figuring out, and there could be some difference between how people classify things. But once you classify it, depending on the way that you do it, you can develop a difficulty because it'll place you in a certain region, and then you can figure out a way to make it the more difficult on the taxonomy. So let's say rings are stationary. Now, every time you do the rings, are they the same? I would say yes. Is the body moving? Well, technically, when you're on it, you're stationary. right? You get on it and you're stationary. You move your body just like in golf. You can swing, but when it starts off, you're stationary. So I would say it's stability. You can disagree with me; it's totally fine. And I would say that you're manipulating an object because you're holding onto the rings. So I would classify it as 1B, whereas Ali would classify it as 1D. And that's a great point. Thank you, Ali, for bringing it up. Is that there's different ways that people will classify them. But remember, the purpose of this tool was to be able, in a rehab setting, to grade where someone's at or the difficulty of an exercise that you're trying to give them, and then sequentially make it more difficult. Link is asking a question. So classifying movements based on this can vary and still be right? Yep. I mean, if there's a testing situation, it's going to be very clear. Whereas if this is a real life setting, there is some gray area. So, like, if the way that you would individually decide to classify a motor skill, it will place you somewhere on the taxonomy. But if it's you doing this classifying to make it more difficult, it's up to you, right? So then it doesn't. It's less important about how you classify it and more important how to sequentially make it more difficult. Joshua's question is, yeah, so as long as there's justification behind the reasoning of a complex task, it can be either, yep. Because the guide or the goal of the taxonomy is to guide you in making a treatment plan to make, or a rehab plan to make things more difficult for the person trying to relearn a motor skill. Okay, guys, that was it. So, feedback. How was the class? Not too difficult or very difficult, confusing, anything? Ali's asking, so if we were making it harder, then, both actually. Because sometimes you may not be able to sort of get someone to be able to move, or like, so you could make things like more difficult by having to manipulate an object, or add intertrial variability. Really, this is the best class so far? I'll take it, but is there any questions? I'm going to stop recording so you guys can ask some questions, but if there's anything that you'd like the class to be aware of, ask now, and then that way in the recording it'll be up there. Should we expect? Yes, you should definitely think about the taxonomy. We've just started off at 1A of excitement, and we're going to end off at like 7G. I should have said 5G as a joke. Okay. Awesome, guys. I'm going to stop recording, and I will see you guys next week. Okay, back to the chat. Chat. There's a question regarding the taxonomy. Oh, crap. I'm missing that. Should give us the table so we could figure it out using that. Yes. Or the question would be more like, what is the environmental? How would you define something? So, like, give you an example: is the body in motion or stable? Like, it would be more specific to that. I wouldn't be like, you wouldn't have to know which one's 1D versus 4D. The best way, like, on the assignment, you have to use the taxonomy, and obviously you'll have it because it's an assignment. But on a test, it would be like, here's an action. Is the function of the action stable or transport? It would be more specific to that. So it'd be like A or B. Does that make sense? Did you say? Oh, so like there's a 12th edition now. Okay. They never gave me that book. What's the picture on the front? Yes, Allison, walking would be no manipulation. Is everyone good? I get my patience here. I gotta go. Sorry. Will we be testing on textbook content? No, just the lecture slides. Oh, it's the same picture? Yeah. Should get royalties. You guys good? Came out. I'm gonna go save some lives. Just kidding. Okay, bye everyone. Yeah, bye. I need to this.